So another type of material which is used for the pavement construction is cement. So basically cements are used for the construction of rigid pavement. Now there are different properties of the cement, and you need to check these properties to find the suitability of the cementous material to use as a road aggregate. Now, these are the different ingredients of the cements. You know all about these things, okay, in your concrete technology classes. So I'm not going to details about all these things, that tricalcium silicate, dicalcium silicate, tricalcium aluminate, like that. So you know all about all these chemical compositions and their properties. Now there are different types of cements are there. So these are the different types of cement. You also know all these things, that OPC, rapid hardening cement, high alumina cement, low heat cement, etc. there. So ordinary Portland cement is classified into three grades. I think you know about this: grade 33, grade 43, and grade 53. Now, grade 43 cement is widely used for highway pavements. It is important that grade 43 cement is widely used for highway pavements since its heat of hydration and shrinkage cracks are less compared to OPC 53 grade. The rapid hardening cement is preferred for remedial jobs when rapid gain of strength is necessary. Remedial job, suppose you have constructed one rigid pavement with the help of your cement, then after some time some portions of the road section is got distorted or got damaged. So to repairing for that portions, you can use the rapid hardening cement so that it will gain the full strength within a short span of time, so that that portion of the road can be reusable within a short span of time. Now there are different important properties of the cement, like fineness. Now this is related to grain size and specific surface. Fineness is a desirable feature because it is related to the intensity of hydration and strength gain. Sieve analysis is the simplest and the most direct method to determine the fineness of the cement. Now, dry cement retained on IS 90 sieve should not be more than 10% for OPC and 5% for rapid hardening cement. So that is your main thing, that is the dry cement retained on IS 90 micron sieve should not be more than 10% for the ordinary Portland cement and 5% for the rapid hardening cement. Now, another important parameter is setting time. Now, workable cement mortar paste using a desired water cement ratio is prepared and time taken for the paste to harden is noted. So you will select a certain water cement ratio like 0.4 or 0.42 or 0.45, like that. Then you will mix this with the cement. You mix the water with the cement, and you will make some paste, cement paste, and you will note down the time taken for the paste to harden. So setting time is an indication of initial chemical reactions of the cement. So there are two types of setting time, that is initial setting time, and another thing is final setting time. Now the minimum initial setting time for OPC should be at least 30 minutes, and the maximum final setting time is about 10 hours for the OPC, that is allowed as per the Indian standard for the road construction. Now another test is soundness test, and you know the soundness test is checked by Le Chatelier apparatus, and this is the ability to resist volume changes as a result of channel reactions with water. So whenever cement is mixed with the water, in that case some volume changes would be there, but the soundness test is conducted to know whether that volume changes would be adverse or not. Then another type of test is there, that is called chemical composition test. So the lime saturation factor of a cement is the ratio of calcium oxide to the other three main oxides present in it. Then strength test. So this is usually determined by testing cement mortar or cement concrete cubes in a cylinders for compression test. So this is similar as your concrete technology. Now, this parameter is important. For the OPC, this compressive strength should not be less than 1622 and 33 MPa at 3, 7 and 28 days of curing. Now there are different type of admixtures which are used in the cement. Now admixtures are used to increase the strength and reduce the water content of the cement. Now some admixtures used are retarders. Now retarders increase the setting time of the cement and you will get additional time to place the cement. Then accelerator will increase the setting time of the cement. So whenever you will mix the cement, if you mix it accelerate with accelerator, in that case it will get hardened very fast. Then plasticizers and super plasticizers increase the workability of the concrete, reduce the water content and reduce the heat of the hydration. That is the use of plasticizers and super plasticizers. Then air entraining agent, it improve workability and increase resistance to frost action. Then pigments impact color to the cement concrete mix for aesthetic purpose. Okay, so suppose you want to color your cementitious material, in that case you can use pigments. Apart from this, there are other type of admixtures like fly ash, blast furnace lake, pond ash, or rice husk ash, clay, different type of calcaneate clay, or other mineral additives supplement cementing properties, etc. can also be used as a admixtures. Now there are different properties of the cementitious material. So first one is workability. Now so basically workability is the property of the cementitious material or concrete where you can mix, place or transport the aggregate with ease. That is the easiness, that how you can mix, place or transport the aggregate, that is your workability. The ease of placement is workability. Now to know the workability, there are different types of tests. Generally slump test is conducted. Now generally slump ranges from 25 to 125 millimeter, and another type of test is there, that is called compaction factor test, and the value of the compaction factor test is ranges from 0.75 to 0.80. Now concrete pavements, now due to their high bearing capacity and increased stiffness, their specific property not to deform under heavy pavement loads is the reason why concrete pavements are used for. Now they are used for parking aprons, taxiways and runway takeoff areas in airports, parking grounds for vehicle of heavy weight, heavy duty industrial floors where different heavy duty vehicles would be there, floors for handling and storage of containers at ports, industrial floors with high requirement in terms of flatness and durability to abrasion and surface exposure to aggressive attack, Suppose use of toxic materials or other type of materials are there where you will use the rigid pavement. Then bridge decks, there also you will rigid pavement. Then road pavements in long tunnels for fire safety reasons, and different expressway where there would be heavy traffic volume, and pavement at toll station, that is also used, your concrete pavements are also used in the pavement at toll stations. Now other uses, besides this there are other uses of the concrete also in the pavement material. First one is soil stabilization with cement and hydrated lime, or cement and fly ash. So this cement can also be used as a stabilizer material. Suppose whenever you are constructing a road, either you cut the portions, or you build one embankment. Now, if the soil of the cutting or embankment is unstable, in that case, you need to stable the soil, or if it is very loose, in that case, it will become unstable. You need to stable this type of soil. In that case, you can use the concrete as a stabilizer materials, or you can use cement grout as a stabilizer material in such cases. So in all these cases, the durability of the stabilized materials against environmental impacts is substantially higher than that of the non-stabilized material. So in this way, considerable savings are achieved due to a reduced thickness of the road pavements, while the environmental advantages are equally important, since there is no use of materials transported from elsewhere or use of quarried material. Then recycling of pavements with cement. So it is recent successful evaluation. So basically that is a very recent type of work. So for the restorations and or upgrade of worn out form of traffic road surface with the least possible environmental strain and a very low cost. That is, in this case, you are recycling the pavement with the cement. So in this case, the material of the old road surface in a depth of approximately 20 to 35 centimeter is being milled and pulverized in specialized equipment together with water and cement. So whatever worn out material is there, you will just uh, dig it up from the pavement surface at a depth of 20 to 35 centimeter, and you will crush that material and mix cement and water with it, and again you will place this over the damaged portion. So basically you are recycling whatever material is there, and for this reason it would be good for the environment, and it would contribute very little to the environmental pollutions. So that is recycling of the pavements with the cement. Then another type of thing is there, that is pervious concrete. So in the pervious concrete, no fines should be provided. So for these reasons, what happens? This cement portion or cement pavement would be very much pervious. Pervious means water can easily get penetrated through it. So this type of pervious concrete is generally used for the sidewalks or in the parking area. But before using this pervious concrete, generally the drainage portions should be very much effective, so that all the water which is penetrated through the pervious concrete should be collected and drained off easily. So this is pervious concrete. Whenever you pour some water, that water will get easily penetrated over it. So this is all about the cementitious material provided for the road construction. Now, as we discussed, there are two types of pavements. One is flexible pavements and another one is rigid pavement. Now, let us discuss about the flexible pavement. So, highway pavements is a structure consisting of superimposed layers of processed materials above the natural soil subgrade. So, as we discussed this earlier, there would be soil subgrade, and over this, there would be different layers of the materials which will ultimately form the pavement material or pavement surface. So the pavement structure should be able to provide a surface of acceptable riding quality, adequate skid resistance with durability and hardness, proper hardness, so that withstand all types of loading combinations. Now, if we go for the functions of the pavement, there are different functions of the pavement. First one is reduce and distribute the traffic loading so as not to damage the subgrade, provide vehicle access between two points under all weather conditions. Suppose there are two destinations that are there, you need to connect these two in such a way so that it can be accessible throughout the weather conditions or throughout the year. Provide safe, smooth, and comfortable ride to road users without undue delays and excessive wear and tear. Then meet any environmental and aesthetic requirements, limited noise and air pollutions, and reasonable economy. So these are the different functions of the pavements. Now there are different requirements of the pavements. So these are the requirements. First one is it should be sufficiently thick to distribute the wheel load stress to a safe value in the subgrade soil. So suppose there are pavement layers are there and this is the subgrade portions. In that case, it would be sufficiently thick so that whenever the load values is distributed in the subgrade layer, okay, that effectiveness of that load will easily get reduced, so the thickness of the pavement layer provided over the subgrade one. Structurally strong, withstand all type of stress and imposed upon it, adequate coefficient of friction to prevent skidding of the vehicles, smooth surface to provide comfort to users. So it should be smooth also, and it should be adequate coefficient of friction would also be should be there. Then produce least noise from moving vehicles, dust-proof surface so that tracked safely is not impaired by reducing visibility, impervious surface so that water could not get penetrated through it and reduce the effectiveness of the subgrade layer, and long design life with low maintenance cost. Now, types of pavements, there are different types of pavements, as there are flexible pavements and another type is there that is called rigid pavement. The flexible pavements will transmit wheel load stress to the lower layers by grain to grain transfer through the points of contact in the granular structure. So in the flexible pavement, that would be granular structure. So what happens? Suppose load is imposed over the surface. Now that load would be transferred by grain to grain. So this could be aggregate, so load will be transferred from here to here, from here to there. So like that load will be transferred from grain to grain. Okay, the wheel load acting on the pavement will be distributed to the wider area and the stress decreases with the depth. As the depth increases, the stress is also decreased. Now, taking advantage of the stress distribution characteristic, flexible pavements normally has many layers, hence the design of flexible pavement use the concept of layered system. So these are the different layers of the flexible pavement. So in the bottom portion, that is the natural subgrade, Then sometimes you can use compacted subgrade, and this total thing is subgrade. Now this minimum height or range of this depth of the different layer, that is important for you. Then subbase course, that would be aggregate course. Then base course, that also would be aggregate course, but it would be smaller fraction than the subbase course. Then the binder course, and then surface course. Now, between this binder course and surface course, there would be one bituminous layer would be there, that is called tack coat, and between the binder course and the base course, there would be another layer that is called prime coat. Now, in the compacted subgrade, what happens if the natural subgrade is low in strength or not effective enough, or bearing capacity is very much low? In that case, compacted subgrade is used, and the height of the compacted subgrade would be, minimum height or range of the depth would be 150 to 300 mm. After that, you will prepare one subbase course. In the subbase course, all the aggregate you should be of proper characteristics, like it should have durable enough, or it should have hardness properties, etc. And the depth of the subbase course would be 100 to 300 mm. So generally different type of materials like slag or aggregate with larger size are used as a subbase course. Now above the subbase course, another layer would be there of that would also be of only aggregate with small sizes than the subbase course. It is called base courses. Now after the base courses, one coating is used, and this coating is bituminous coating is used, and over that coating, one another layer is used, that is called binder course. So in the binder course, generally bitumen is mixed with small portions of the aggregate. Okay, the size of the aggregate would be lower, so that is basically a binder course. So over the binder course, another layer would be there of a like bitumen primer thing, that is called tack coat, and over the tack coat, surfacing of the bitumen would be there. Okay, in that case, bitumen would be mixed with fine grade aggregate, and it would be surface course. Now over the surface course, to make it not unpenetrable, in that case another primer type bituminous material would be added over it, and it is called seal coat, which will seal the perviousness of the bitumen surface. This is all the different types of layers of the flexible pavement. Like seal coat is a thin surface treatment used to waterproof the surface. So I've discussed all these things: surface course, binder course. So see, this is the layer provides the bulk of the asphalt concrete structure. Its chief purpose is to distribute load to the base course. The binder course generally consists of aggregates having less asphalt and doesn't require quality as high as the surface course, so as to replacing a part of the surface course. So that is basically a binder course. In the binder course, bitumen content would be very much lower. And surface course is the layer directly in contact with the traffic loads, and in generally contains super quality materials. It provides characteristics such as friction, smoothness, and drainage, etc. Also, it will prevent the entrance of excessive quantities of surface water into the underlying base, surface, and subgrade course. So basically, they are the dense graded asphalt concrete. So whenever you are constructing the surface course, that surface course, whatever aggregate you are choosing, that aggregate should be dense graded. Okay, so that all the types of voids can be eliminated. So there are different types of flexible pavement. So first one is conventional layered flexible pavement. So conventional layered flexible pavements are layered systems with high quality expansive materials are placed in the top, where stresses are high, and low quality materials are placed, or cheap quality materials are placed at the bottom. Then another type is there, that is called full depth asphalt pavement. Then full depth asphalt pavements are constructed by placing bituminous layers directly on the soil subgrade. So this is more suitable when there is a high traffic and local materials are not available. In that case, full depth asphalt pavement is used. And another thing is contained rock asphalt mat. So contained rock asphalt mats are constructed by placing dense or open graded aggregate layers in between two asphalt layers. So modified dense graded asphalt concrete is placed above the subgrade, will significantly reduce the vertical compressive strain on the soil subgrade. So this is all about the today's class.